Hey everyone, and welcome to another episode of the Digital Dentistry Decoded podcast. We are here with the Asiga boys. We are very lucky. Two guys from Asiga, and this is one of the biggest digital dentistry companies in 3D printing. They had a huge IDS, so I'm really curious to hear from them how it's been going, because that feels like almost like a year ago, IDS. The year is just flying. So Cory, Bryce, welcome to the podcast.
Thank you.
Thanks for having us.
My pleasure, guys. Cory, we've spoken a number of times, and everyone knows who you are, I hope, by now if they listen to the podcast. But Bryce, I understand you lead the kind of the education arm of Asiga. Is that correct?
Yeah. So a lot of educational activities that go on over here in the United States. So we do a lot of educational courses, webinars, things like that. A lot of hands-on courses. And so part of my responsibilities are kind of spearheading those activities.
That's super cool, man. Well, you're the right guy to talk to. And Cory, of course, please, we can't not let you introduce yourself again for those who haven't listened to the podcast before. What do you do at Asiga, my man? I know you are General Manager of the Americas, I think it is, or...
Yeah, so I'm the GM for the Americas for Asiga, so I handle like business operations for North and South America. But like everybody at Asiga, I dibble dabble in a little bit of all aspects from R&D to marketing to technical support to all aspects, and so it's amazing to be able to be part of the team and always great to be part of this podcast.
The pleasure is mine. And again, look, I know for you, man, it's like 5 a.m. in the morning, so I really appreciate you waking up this early. I think as well for you, Bryce. What time is it for you?
Same.
Oh, man. Geez, what am I doing to you guys? Well, if it's any consolation, it's 9 p.m. here, so we finally found some sort of time that fits because we're on other ends of the globe. But look, let's just get into it. Asiga, I think anyone who's into digital dentistry or 3D printing should know who Asiga is. You guys dominate, and I don't think that's a overstatement of lab 3D printing. And now you're really getting serious, I would say, about chairside, given some of the releases at IDS. I mean, for those who didn't go to IDS and for those who didn't see all the publications about IDS, please, guys, let's just get into what did Asiga release, because you had some fascinating things.
Yeah, so we had how many releases? So we had we officially released the Cure. We officially released Genira. We officially released the funnel. We officially released the crown kit. We officially released 4 new materials, and then we officially released an update to the Max 2, and then we officially released the PrintPods. And so like it was crazy leading up to it.
That is insane, man. That's a huge freaking IDS. And although, let's say, Midas is getting a lot of attention, you guys are still kind of, I wouldn't even call it the underdog, because let's be real, you guys are one of the biggest 3D printing companies. It's nice to see you innovate. Now, I want to click down on each one of those things and just really talk about what these releases are. Let's start from the top, guys. What was the first thing? You said a Cure, and I'm really glad to see a Cure. It was something that was kind of the Achilles heel of Asiga for a long time. A lot of people poked fun, including me, at the fact that you guys didn't have the workflow, and everyone keeps saying you guys don't have the workflow. Well, now you do. So you have the amazing printer, you have the wash, and you have the Cure. The wash, I think, is coming, but let's jump to the Cure. What's special about it? Please, by all means, go and tell me all the details.
Yeah. So the Cure is really a revolutionary curing unit. And I know we hear that word revolutionary a lot. Everyone says it's revolutionary. But anyone that's familiar with Asiga, they know that when we release a product, we don't release a Me Too product. We are always looking for ways to innovate on anything that we release. The Cure is no exception. So, we identified a big problem with curing units in dentistry, and it's dose curing, right? So the best way that we have found to create an analogy for this problem that we have with curing units is by comparing them to a microwave. So we call it the 2 potato problem. So let's say you want a baked potato and you want to just throw it in the microwave, and you want to hit the timer for 5 minutes. When it comes out, it's cooked. It's ready to eat. Well, what happens if your husband or your wife or your kids also want a baked potato? Let's say you need to make 3 and you throw them in the microwave, you hit 5 minutes, they come out, they're not cooked. All 3 of those potatoes have had to compete for the same number of microwaves bouncing around in that chamber. Curing units actually work pretty much the same way. So when you let's say you print a splint, right? You put that splint in a curing unit, you hit the timer that it tells, or you hit the time that it tells you on the bottle of material, and it comes out and it's properly cured. But if you've printed more than one, as people typically tend to do, and you put all of those in the curing unit and you set the timer for whatever it says on the bottle of resin, when those come out, they're not actually properly cured, because just like the potatoes, now you've got those objects in the curing chamber that are competing for the same amount of photons, of light photons bouncing around in that chamber. And this is a problem that we identified pretty early on and really realized that we had to find a solution for. And so with the Asiga cure, it actually addresses this problem by utilizing what we call scientific dose curing. So essentially, the printer is able to recognize how many objects you have in the chamber and will automatically adjust your curing time to make sure that everything's actually getting the proper cure. So that's really the big feature on the curing unit. There are some other really amazing features. Another one of those features includes vacuum curing. So as we know, a lot of materials require curing without oxygen, so in an inert environment. The best solution for the most part that we've had up until now is curing under nitrogen gas. Why nitrogen? Because it's the cheapest gas other than oxygen that we have available, basically. And it works. Nitrogen works, but it is a little bit cumbersome having to make sure you have a nitrogen tank, make sure it's hooked up and regulated properly. So we wanted to make an easier solution. So we built a heavy duty vacuum pump into our curing unit. So the curing chamber is airtight. If the material that you are printing requires curing without oxygen, now you have the option to just simply pull vacuum instead of using a gas. Now, I do want to add a caveat. There is still a nitrogen port in case you do need nitrogen for some reason. There is still a nitrogen port. However, the cool thing is with our curing unit, if you are going to utilize nitrogen, the curing unit will actually pull vacuum first, and then it will essentially shoot an express shot of nitrogen into the chamber. And because the chamber is airtight, the curing unit doesn't have to constantly pump nitrogen into the chamber. It basically just needs to shoot it in there once, and you're good to go, and you don't waste a lot of nitrogen like you do with other curing units.
That's super interesting, man. You guys had a couple of really fascinating points. Well, one, you cover all the bases. I'm not sure of any other printer cure unit that comes to mind that has a vacuum in it. Do you guys know any?
I think there's, I forget the brand, but there is another curing unit that does have onboard vacuum. I think there's actually 2 more that have it. And so like the vacuum part wasn't the most novel innovation in it. Really, the most novel innovation is the applying dose curing, as Bryce mentioned, which solves that 2 potato dilemma. What that gives us the ability to do is that it gives us the ability to regulate instability, that final post-cure results, and also will improve like shade consistency as well. And so that means if a office is using it, a dental office using it, they're going to get optimal shade output every single time, which with 3D printing crowns or 3D printing all-in-X restorative work, well, as soon as you place it in a post-curing unit, it changes the color ever so slightly.
Yeah.
And so what we've found with other technologies is that even if you had like 5 of the same curing unit, each one would give like a completely different output. And therefore, like each curing unit, you'd have almost a completely different shade. And with the cure from Asiga, with our dose curing, we're able to solve that problem. And so regardless of the curing unit from Asiga, regardless of where it's located or what company has it, if your material is supposed to be an A1, it's going to be A1. And so it's pretty amazing that we're able to integrate that, and it's safer overall. And so we're able to really make sure that each part reaches its proper cure before delivering it to a patient.
How's it doing that? Is it software side, like it's just what you printed, then the cure talks to this printer software and it knows you printed 2 or 3 splints, or is it actually doing it within the chamber, somehow reading what's in the chamber?
It's doing it within the chamber, and so we do have the ability for like the curing unit is daisy chained to our composer software and 3D printers on the network, so it knows what cure cycle it needs to run next. But but the actual magic happens inside, and so the curing unit has 4 sensors inside of it that detects the amount of light output and the amount of light that's being blocked, and automatically is able to dynamically adjust the dose of cure needed for the parts for that given resin.
It's super cool, man. I was going to say, if it was just software side, that would be way less impressive than if it was chamber side. Because some people, like you say, I don't know, you guys will have the data more than me, but I mean, most practices, at least in our practice, would print 1, 2, 3, and then maybe run the cure at the end of the day. And I really like it. That's fascinating how you guys are solving that. Even though it might be one of those things where I don't want to say you created a problem and solved it, because it's obviously a problem, but I actually haven't heard that be spoken about industry side. Maybe you guys in the actual companies, but I haven't heard a lot of companies bring that up and it makes total sense. The more things that we put in the cure chamber, the less, power or photons, as you put it, are getting absorbed by each piece.
I think a lot of people have recognized, but just since nobody's had a solution for it, it's just been kind of brushed under the rug, so to speak. But it's something that we've observed for a while, and as we tend to do with our products, we did this with the Max when we released it way back in like 2016. We tend to fix problems that most people don't even realize are problems yet, and the cure is no exception to that.
That's super cool.
I think people knew it was a problem, but they didn't know how to investigate it or know how to solve it, and we're able to. I mean, we have amazing engineers, we have amazing leadership, and all these ideas come from within, and we're able to apply these ideas and find solutions to the problems that are in the industry.
All right, so I don't want to cut to the chase and put you guys on the spot. Is a wash here yet, or is it one of those things that you guys don't want to just release 2 Tupperware containers and call it a day, and you want to actually innovate on the wash? So do we have an Asiga wash?
It's in the works, but you're absolutely right. We just don't want to have a Me Too product. And so, like Bryce said in the beginning, everything that we do here at Asiga, we want to make sure that it's innovative and it's next generation and it's industry leading. And the wash is something that we feel that there are some problems with wash units today, and we have some ideas on how to solve those problems, and it'll just take a little bit of time to execute it, but we will have a wash. So that is coming soon. As for when, it'll most likely be, there's a higher chance it'll be next year before this year. But until then, there's quite a few wash solutions that are available. I still recommend the ultrasonic cleaner. It's the cheapest solution for cleaning your parts, and it's actually one of the most effective ways for post cleaning. But there's other, cleaning solutions that are out there that are very viable.
Cool. All right. So what was the next thing that you said, Cory? We should probably have a list. I'm going to put you on the spot each time. I'm going to be like, what was the next thing? What was the next thing? You said the cure, and then what was number 2?
So number 2, let's loop them together. So they're group them together. So there was 2 and 3, and those were 2 new softwares that were released. And so I'll talk about the funnel software, and then if Bryce can actually go run down on the Genira software. And so the first software released is called Asiga Funnel. The funnel software is, so it's going through a final stage of beta right now. It'll be available in the Southern Hemisphere first, most likely Q3, and then later in Q4 will be rolled out to to North America, and then the rest of the globe after that. The funnel software is exactly what it sounds like. It is a funnel for work to go through. And so what that means is that the end user now can think about it as it's a online AI cloud-based composer software, but you actually don't have to interact with the composer nesting software interface. And so an end user will simply upload all of their STL files into the funnel. The funnel then will take a look at every STL file, automatically categorize it for what the file is. And so let's say if you uploaded 10 surgical guides, 10 splints, 5 denture bases, 5 all-on-X's, and 30 models, it'll go through and it'll automatically categorize all those parts together, group them together, and then start building your jobs for the printers on your network. And so it'll do the automatic orientation, automatic supporting, automatic nesting, and then transfer the data to the open printers that you have access to. And so it does essentially all the work that a technician would have to do with managing the composer software and uploading builds, and it does it all automatically. It also provides fleet management control, so you can see what machines are open, what machines are not, and gather some statistics on the machines themselves. And we also have the ability to tie in design services as well. And so companies such as Evident or 3Shape Automate or Dentbird and a few others, they all have integrations that are being worked on where an end user can simply log into their funnel, access their AI design portal, and have any designs that they're working on automatically drop into the funnel software, and the funnel does the work for them to get it to the printer. And so it's like a complete automated nesting software, and it's pretty amazing. It is subscription based, but it does take away a large percentage of the work for clinicians and lab technicians, giving them the ability to focus on what they really need to be doing in the lab versus spending time playing Tetris on the parts for 3D printing.
What's the, I'm going to ask, I'm that guy, what's the subscription cost? Have you guys landed on one yet?
$1 million. No, the subscription cost it's getting finalized, but it'll be surprisingly inexpensive. I think it'll maybe only be it'll be based off the number of parts you do. And so check back in. We have a website for the funnel. So if you go to asiga.com, we have a software option that you can view the funnel application and you can familiarize yourself with it. Come back in about a month or so and you should be able to see pricing for that.
Interesting. You know what's really fascinating to me is that digital dentistry, as the market matures, because I would say it's more of a mature market now. A lot more companies are doing similar things where, like, for example, VHF, a milling machine company, their main release at IDS was all software and similar sort of thing, like automatic nesting, AI nesting, and optimizing your discs and all of that. And the other interesting trend that I'm seeing is that companies working together. I mean, if there was one thing that came out of IDS 2025 is that companies are collaborating together to offer workflows. It's not just about I have a printer. It's not just about I have a scanner. It's all workflow based. So I find it interesting that you guys are working with these CAD companies to bring it all together.
Yeah.
Okay, so we have another piece of software, which is exciting, and it is called Genira. I think probably on the software side of things, the request that we get more than anything else is for model basing, so having a model builder built into our nesting software. We get that request a lot, and now we have a solution. So Genira is essentially an AI model building software that users can import their scans. They can set up essentially like a template for how they want their models to be built. And then the software will automatically essentially build their models and allow users to print those really in any software, but particularly Composer. So it's pretty straightforward. Model building software isn't isn't necessarily, breaking the mold in a huge way, but we do recognize that it's something that our users ask for a lot, and we wanted to listen to that feedback and provide a product for those people that need it. So it works really well. There's not a whole lot of detail to go into on it on a model building software, but it works incredibly well. Similar to the funnel, it will be. We're still working out if it's going to be like a subscription based or like a pay per model type thing. It'll probably be some kind of tiered system more than likely. Like Cory said, stay tuned. We will be releasing final pricing information in the coming weeks, but similar to the funnel, I think people are going to be pretty surprised by how affordable it is.
I was going to say, please say it's free, but I guess I'm dreaming. Obviously, you guys need to accrue some revenue from all of the software development. I mean, yeah, Model Builder is really interesting because Medit had the best model builder. Now they charge for it. And now everyone is kind of scrambling. We don't know what to do. I mean, if you have a Trios scanner, use their model builder, which is free. I would have said what would have been interesting would be to make it free, but locked to Asiga users. But, I mean, you guys have much smarter business guys out there than me, I assume.
Well,
Yeah, no, I mean,
we're not going to lock
go ahead.
anybody into something or out of something. It's not what we do.
Fair enough. Yeah, you guys are the OG open printer and definitely ran with that. You were going to say something, Cory? Sorry.
Oh no, I was just maybe there's something we can do where a concept around like the first X amount of cases are free, and then after that, we introduce a like a pay-per-click type.
Well, I would have said, I'm
service.
just spitballing here. And again, look, I'm not going to change your whole business model. I would have said, buy X amount of resin and you get the model builder for free, because I feel like model builders in this industry to pay for it, I'm just speaking out loud here, and I'm happy to be proven wrong if you get a rush of people paying for this thing. It's one of those things that clinicians and labs, I guess, I mean, I'm a clinician, I speak for myself, we really don't like paying for model builders. And a lot of people just go back to Mesh Mixer. And even though it's not the best to use, I mean, having to pay per model is a tough gig.
Yeah. Just out of curiosity, what do you think would be an acceptable price for model builder? Let's say all the free services end forever. There's no turning back, and now there's a charge for it. What do you think like that optimal fee is for a model build model?
Genuinely, like a couple of bucks. I feel like where it gets a bit iffy is that some companies are like, $20 and a month and that sort of stuff, and that's a bit weird. But anyway, okay, so that's 1, 2, 3. So far, so good. We're leaving the best to last, obviously, with the pods, but let's talk about the next thing. What was it, Cory?
So let's talk about the next things that we released. After that, we released, just to recap, we released 4 new materials, and then we released the crown kit. We updated the Max 2, and then the PrintPod. So let's dive into the 4 new materials.
Sure.
And so we have 4 new materials that we announced at IDS. One of them is just a new color for our custom impression tray, so Denta Tray. And so Denta Tray, the original color was turquoise, and we received feedback from quite a few clinicians that the turquoise color was too close to the same color of blue as your impression material. And so you had a difficult time seeing like shallow spots in the impressions themselves. And so we introduced Denta Tray Orange, which will give that contrast if you use a blue or a purple base color impression material.
Do you guys just make it like white or black? I mean, we also use orange PVS, but like they're all similar.
I think you could have literally we could probably make like every color and still there'd be a color that somebody wants different, and so so I think if we have the two broadest ranges, so if we have turquoise blue and then like bright orange, then that's got to make at least 50% of the clinicians happy. And so we'll try to get.
It's just funny to me because like blue and orange are literally like impression materials. Like I think of them, PVS comes in like purple or blue and orange, but I'm sure you'll be fine. I mean, hopefully people aren't taking too many PVSs.
Yeah, hopefully. Yeah, I mean, they should be transitioning over to intraoral scanning unless they have some weird challenging case that they have to still do PVS. But so that was the first material that we released. Then the next three materials are brand new materials for us, and so the first material is called Denta Retainer, and so this is a hard clear resin that is meant for like fabrication of like Holly style retainers, not for Essex style retainers. And so I know a lot of people are pretty excited about printing Essex. This material is not meant for Essex retainers. It can also be doubled down as a hard split material. And so if you need a hard split material, it would work for that. We have also Denta Splint, which is our soft splint or comfort splint material. So it's a splint material that will relax once it reaches the 36C in the oral cavity. And so we're pretty excited about that material. I've also performed some tests with the material, the Denta Splint, in trying it as an Essex style retainer, and it may be possible. So that material is a little bit it's not like super soft not as soft as some of the soft split materials we see on the market. So it does hold a little bit more of its firm qualities behind it, but still comfort. I think there may be an opportunity for using it as a Essex style. So that's to be determined after further testing. So we're excited to bring both of those materials. And then the final material that is probably the most exciting for me and Bryce is a material that we called DentaFlex. It is a flexible RPD, removable partial denture resin. And so, that we're extremely excited about. All of these materials are going through our regulatory processes now. We're hopeful that we'll have them have like the regulatory clearances by the end of the year. And so please stay tuned for that. The beautiful thing about each one of those materials that we just discussed, they're all $175 a kilogram. That's retail price. And so it's some of the most affordable materials for these applications on the market, making it some of the most profitable materials for you as a clinician or for a dental laboratory.
Interesting, man. And it's fascinating how you guys are talking about the Essex retainer sort of issue. And I think that also almost gets into the issue of printing aligners in a way, where a lot of these materials there. What's your thoughts while we're talking about materials? I'll just jump in. What's your thoughts about printing aligners? It's obviously it made a lot of noise and hype in the market for a little while, and seems to have died down. Look, I've said it on the podcast before. I've never been that impressed, and I've tried. Do you think we're making grounds on printing aligners directly?
I think the materials need to get better for it. The post-processing needs to get better for it. Printing aligners, it's kind of this unicorn, right, in dental 3D printing, because it's actually a quite difficult material to engineer for several reasons. An aligner resin has to check a lot of boxes that on their own are difficult to achieve. But when you combine all of those properties together, it is very, very challenging. So you have to have a material that is perfectly clear, right? You can't have an aligner that's tinted yellow or tinted purple like you can with a splint. You can get away with that a little bit with a splint. You can't get away with that with an aligner. So that right out of the gate is really difficult to achieve. And then you add on top of that, you have to be able to print it consistently and reliably at a very, very small thickness. So 0.3, 0.5 of a millimeter. We're talking about thin objects that you have to be able to print those reliably. And then the final product at that thickness has to be rigid enough to be able to move teeth. So when you take all of these qualities and you try to cram those into one resin, it's really, really difficult to do. I love the idea of printing aligners, and I think we're going to get there. I'm not worried about long-term having a good solution, but it's challenging. And I think where we've been in the industry is that it kind of makes more sense to print the model and still do a suck down. And I know that's like heresy coming from a digital dentistry guy. But I also try to stay in touch with reality, and I think what a lot of people have realized is that when it comes to their time, that still kind of makes more sense when you factor in post processing and and the challenges of post-processing clear aligner materials, for a lot of people, it still makes sense to just print the model. I think we'll get there, but it's going to take some advancement on the material science side of things.
I also think when you consider the maturity of post-processing thermoform aligners compared to post-processing in printing, it's a totally different beast. I mean, you got these endless machines of laser cutters and millers and product line kind of machines that do aligners, and they do them to a really high standard. I mean, a lot of them are used by the big aligner companies. So definitely the post-processing is an issue. And I love how you talked about the printing it clear. I think I'll add one other thing that I've noticed is that a lot of these companies that are promising aligner printing directly, yes, you can print it clearly, but does it stay clear in the mouth for a week?
Mm-hmm.
And it's funny because just behind the camera here, I've actually got these printed aligners that I tried in my mouth. I don't want to get up because on camera you're going to see I'm not wearing pants or something for this podcast. But it's literally terrible. It looked clear. I put it in my mouth. After 3 days, it goes cloudy. And in a really not good way, like a disgusting way. And I think that's the other issue, is that it has to tolerate that disgusting oral cavity for a week, 2 weeks minimum.
Yeah. I mean, it's so hard to compete with for aligners. It's so hard to compete and produce something that's equivalent to the vacuum form sheets. I mean, those sheets of plastic. I mean, it's got to come out crystal clear every time, unless you burn it, of course, when you're doing the vacuum forming. And
they have multi-layers. They're soft and hard and different thicknesses for different strengths. It's so mature.
Yeah, it is. And the other thing, like the automation for the trimming of the aligners, it's amazing. Like I was able to watch one of the laser cutting machines like 2 years ago at a trade show, and I was blown away by it. Yeah. I was like, this is insane. Like how super simple it is, and it like the aligner comes out cut like perfect, and like the edge is already practically finished. Like maybe if anything, maybe you hit it with the fiber wheel, maybe you don't, and you're happy with it. And so it's pretty wild. That's a limiting factor. And I think that's why if 3D printing aligners was really here, or really a strong viable option, then I think we would see so many manufacturers that are switching over to that. It's closer, and maybe in some regions it's close enough, but depending on what your standard is, it seems that vacuum forming is still superior, but they both have their like labor intensive activities on both sides. And so it'll be interesting. I think give it another year or two, and we'll see how mature that market becomes.
Yeah, totally, man. And as you guys know, 3D printing is changing radically. I mean, even the crown thing, which we're going to jump into, that's changed a lot. I was one of the first guys to say, it's kind of rubbishy, and we talked about it, Cory. We were like, this is kind of weird. Yeah. And now I'm doing them, and I'm like, wait, this looks half decent. What's going on here? So anyway,
yeah. What's
the next release?
So the next three things that we have are the crown kit, the updates to the Max 2, and then the PrintPods. And so I say we like the crown kits and the PrintPods. They're on the same category, but I want to split them between the Max update, just so we prevent any sort of confusion between both topics. And so, Bryce, you want to tell us about the crown kit, and then I'll dive in on the Max 2 updates.
Yeah, absolutely. So the crown kit, actually, you can see one right there behind Cory. So we have released crown kits for the Max series machines and for the Ultra series machines. I think probably all of us are kind of familiar with what a crown kit is by now. So essentially, it's really simple. It's a small build plate and it's a small resin tray. This is something that we've needed for a while. And really the big advantage, there's two advantages here to having a crown kit, and it's speed of printing and its material consumption, or which boils down to material cost. So on the speed side of things, when you have a smaller build plate and a smaller tray, you can essentially accelerate the mechanical processes of the printer because the resin doesn't have to flow as much in between each layer, because it's just a really, really small amount of material, a small tray. So We're seeing, depending on the material, on average, you can print anywhere from 6 to 12 restorations in anywhere from 10 to 15 minutes, depending on the material. So significant speed increase with the crown kits. The nice thing, I think the biggest benefit is material cost. So, and this really is especially true for clinicians. So you can see that the material or the material tray it's a really small, area. And the nice thing about this is instead of having to stock, full kilogram bottles of material that you're going to be using for restorative printing, you can just get the little bottles that a lot of the companies sell. And this is really important because resins have an expiration date. Some people may not know this, but there is an expiration date on that bottle. And crowns use very, very little material. They don't use a lot of resin. And so let's say you've got a case that you need to print in a more uncommon shade. Like let's say you've got like a D2 or a D3 that you need to print. And you buy, you don't have any material for it. And now you have, if you don't, without a crown kit, you have to buy a full kilogram just to be able to fill up the tray. And you're never going to use all of that. You're never going to print enough crowns to go through an entire kilogram of D2 or D3 resin. And so essentially you're going to be wasting a lot of that and just throwing it away. And that's just money down the drain. And these materials are not cheap. Some of them are $1,000 or more for a kilogram. So now you can buy the smaller bottles. There's a lot less waste, a lot less upfront cost to get started with your restorative 3D printing. The Max Crown Kit is compatible with all Max printers. So that's the current Max 2, the Max 2 that we, I guess, released a year and a half ago. The original Max UV, all of the Max printers, they are compatible and backwards compatible with. The Ultra Crown Kit is compatible with all Ultra machines. So that's the Ultra 50 and the Ultra 32. So, we're big on backwards compatibility. Is something that's important to us, and making sure that all of our users have access to like new product accessories that we release. And so, I think you're going to see almost all of if not all of the accessories that we launch for machines are backwards compatible in some way for the most part moving forward.
That's super cool, man. I mean, I love you guys. I will be that guy that says what took so long, but I'm glad it's here because I think anyone who's serious about chairside 3D printing has to have a crown kit. We saw, Sprint Ray and then Shining 3D do it, and I'm glad you guys have it. I think Accurata maybe as well. I don't know. Can't remember anymore. It's all a jumble, but I'm glad you guys have it. And it's exactly for your point. I mean, a lot of dentists may only print a couple of crowns a week or something. I'm curious though, because you spoke about the printers, and before we get into the Max 2 updates, for those who are not familiar with the Asiga portfolio, can we get like an elevator pitch of what's the difference here? Because even I'm getting a bit confused.
Yeah.
So we have the Max. You said the Max, and you kind of rolled your eyes a year and a half ago, the Max 2, sorry. And then we have the current Max 2, which I'm really curious what the difference between those two are. And then we have the Ultra with the two wavelengths. I personally still don't get why someone's buying one over the other. I'm really curious to hear the whole portfolio and the elevator pitch, and then we can get into updates.
Yeah, so really it boils down to, for the most part, production capacity generally. So we essentially have three families of machines, right? We have the Max series, which you can see behind Cory. I've also got one right back here behind me. It's our small, compact machine, right?
The beast that pretty much changed the game, man. It does, for its footprint, it's an absolute powerhouse.
Yep, absolutely. In this, I think most of us here at Asiga see as the ultimate chairside printer, just because of the footprint. As we know, clinicians oftentimes are pressed for space. The Max is a small form factor with a powerful punch. Next, we have the Ultra, which also is a desktop machine, but it's bigger, right? So the footprint's bigger. It's got a bigger build plate. And then we have the Pro 4K, which is the larger freestanding, high volume, high throughput machine. Now, the best way to understand this is all of our machines utilize the same technology. So we're talking DLP machines, 385 nanometer wavelength, active layer monitoring, internal radiometer. They all utilize the same technology, same base technology in all of our machines. The main difference is going to be production capacity. So on the Max, you have a fairly small build plate. It's more ideal for clinicians. On the Ultra, you have on the Ultra 50, you've got a much larger build plate, about twice the size as the Max. And then on the Pro 4K, you have an even larger build plate that's geared towards labs for high production printing. The Ultra does have a couple extra bells and whistles on it. But for the most part, the main differences between those printer families is going to be production capacity.
So what about with the Max to the Max 2? I think that was just like a lick of paint, I think, and make it look a lot better, and the outside's better. I mean, I wrote a blog about it a while ago when you guys gave me all the updates. What was the difference between the year and a half ago Max 2 and this Max 2? I didn't hear this little thing.
So the Max 2 itself, it received two notable updates. And so you'll notice right away, if you were to look at your, do you have a Max 2 or a Max UV at your facility?
I have a Max UV.
Like the Max UV and the first generation Max 2, the way that the resin trays are clamped down, it has like the springy, like wings on the sides that you have to clamp over. And so we eliminated those, and we have a slide lock mechanism that matches just like the Ultra and just like the Pro 4K. And so it makes it a little bit easier for an end user to operate the system. And then the next thing that we introduced was better heating technology. And so the original Max UV and the first generation Max 2 can only get up to about 30 degrees Celsius, about 30 to 35, 10 degrees above ambient. The Max 2 can now get up to about 50 degrees Celsius, which allows us to alter the viscosity point for the different materials, and make some materials that maybe were more challenging to print, or maybe weren't developed yet or couldn't be used on the Max 2, now can be utilized on the Max 2. And so it really opens up a door for resin developers to tap into that next generation resin and apply it in a very affordable output device. And so the Max 2. And so those are the two main updates that we integrated in. And then with the Max 2 Phase 2, it already comes ready for essentially the PrintPod system to be utilized. And so I say we dive into the PrintPods.
I just had one last question before the exciting PrintPod. Sorry, and I hate to keep banging on this because I'm sure
you're good.
Why don't you just read the website, man? What's wrong with you? I'm sure that's what you're thinking. The Ultra 2 wavelengths.
So the Ultra primarily comes in one wavelength, but we have two different build platform sizes. And so we have an Ultra 32 and we have an Ultra 50. So the Ultra 50 is the larger build platform size, and then we have the Ultra 32, which is the smaller build platform size.
I mean, I think the 32 and 50 is like pixel density or pixel size.
Yeah. Yeah, pixel size.
Sorry,
yeah.
Not wavelength. So the bigger one has the bigger platform.
Yes. Yeah. So the Ultra 50 has a 50 micron pixel, and it's a bigger platform. The Ultra 32 is a 32 micron pixel, but because the pixel size being smaller, your print envelope is smaller. The main benefits with the Ultra 32 over the Ultra 50 is just the pure like the resolution that it can achieve. And so you can achieve a little bit higher accuracy. Both machines are completely acceptable for dentistry. Most clinicians and lab techs in laboratories, they're going to gravitate towards the Ultra 50 and utilize it because it has a larger build envelope. The Ultra 32, you have to remember, we're not just in dental, even though we're primarily focused in dental. We have other industries such as jewelry or microfluidics, which the Ultra 32 is seeing a strong fitment in those industries. And so, so the Ultra 32 is still an extremely powerful machine. If you're a prosthodontist or a dentist or a lab technician that wants the most accurate thing and you don't really care about build envelope size, Ultra 32 is a pretty amazing machine. But if you need that extra large or the larger build platform size, then the Ultra 50 is the way to go.
All right. Well, boys, I think it's time. The pods, and I also saw the shaker. I want you to talk about the post-processing shaker that you guys had. I saw it.
Yeah, let's dive into the PrintPod. So Bryce and I have spent a lot of time with our material partners and with the team when working on the PrintPod project, and so we're actually quite intimate with the project itself. And so, what was it? It was I think it was like last November. We all sat down and we had a meeting. We pitched quite a few different ideas and concepts for what we felt was like the best clinical like application or clinical machine. So we spent quite a bit of time on that, and we're looking at like what are the main problems that we see in the clinical market. And so the main problems in the clinical market we see is that the clinicians that want to produce and fabricate chairside restoration extremely fast. They want it to be extremely easy, and they need to be hygienic and clean. And as you know, with chairside 3D printing, if you're pouring out a large bottle of material into a tray and then you're pouring it back into the bottle, or you're mixing the resin, it's quite nasty, right? And it can be quite messy for your patient to be exposed to. And then the other aspect is that it's quite expensive, which Bryce alluded to with the crown kit. You know, buying a large bottle, even buying like the 3rd kilogram or a half kilogram bottle, it still can be upwards of $500-600, and so it's quite pricey. Even $800 for some materials, and so it's quite expensive just to be able to utilize some of these resins, and you may not actually utilize the full bottle before it expires. And so we've decided to develop a cartridge-based printing technology. Now, unfortunately, I don't have any cartridges here. They're all in Australia at the main headquarters, but it's simply just a little cartridge that contains the cartridge itself is the resin tray. It has the build platform built inside of it, so a stem, and then it has a lid to the tray, which is a lid to the little cartridge itself. The cartridge will simply be locked into the center of the Asiga Max system. You will have to purchase an adapter plate and a build platform adapter to be able to utilize the PrintPod system. And you can start fabricating crowns chairside in as fast as 9 minutes for some materials. The PrintPods are reusable. And so a lot of cartridge-based printing technologies, it's like a one and done type situation. You spend $20, $30, or $40 for a cartridge and you print one crown, and next thing you know, you're throwing it away and you're wasting the residual resin inside of it. Our cartridge technology is reusable up to 5 times. And so you can print up to 5 times, and on each build, depending on the size of the restoration, you can fit like one larger crown, maybe 2 smaller crowns. I've been able to print up to about 4 veneers on the build platform and print them. And because of the technology, we're able to tap into even more unique chemistries, like true permanent crown materials. And so Bryce and I, we had the luxury. We were in Australia a couple weeks ago, and when we were visiting the main headquarters, we got to play with the new next generation material, which has not hit the market yet. It's 80% filled ceramic, and we were able to print. We printed 4 veneers. I think it was in a total of 11 minutes, and the material felt and polished and ground, like you grind on it, just like lithium disilicate. And so it was so impressive to see like these restorative materials and how they can be utilized. When we first released the PrintPods, there were quite a few people that said, it's just another resin tray, or it's just simply a resin tray. There's nothing special about it. And they said that you wouldn't be able to print the highly filled materials. Printing highly filled materials is not a problem with our system because it's quite robust. And so printing the 80% filled material was no problem at all. And we actually have a formulation that's close to 90% filled, and I don't see any issues in being able to print it.
All right. So there's a lot to piece into this. Again, I'm going to be that guy. I know you can't be that guy because you work for Asiga. I mean, to me, this looks like just a direct response to Midas. Would you say that's a fair comment, or you guys were thinking about this before Midas, and there's no shame in that. If a product comes on the market and they're like, we're going to disrupt everyone, was this just a we can do it as well kind of thing?
I don't see it so much as a response. Obviously the Midas generate a lot of buzz. And I think it's a cool product. I think we wanted to kind of address some of the issues that not just the Midas, but there have been other chairside printers on the market that have come out, and I think they all share a lot of the same issues. I think one of the big issue is reusability of the cartridges. I think this is a huge problem because one of the driving forces clinically is cost per unit, right? That's what a lot of this boils down to, is how much is this going to cost me per unit to produce? When you have a cartridge that can only be used one time, your cost per unit skyrockets compared to if you had a cartridge that you could use multiple times. So with our print pods, they're actually reusable. So you can get up to 5 print jobs out of them, and your cost per unit is going to be really low. It could be anywhere from $6 to $10, somewhere in that range, depending on which material you're printing. And it keeps the cost per unit really low. The other big thing that we wanted to address is not having to have a dedicated printer that can only do one thing. I think this is a big issue. I mentioned earlier how clinicians, they tend to not have a ton of lab space. They oftentimes don't have a lot of bench space for equipment. And I think it's an issue having, if you have a machine and all it does is print crowns, right? But if you want to print your models, or if you want to print your splints or guides, now you have to buy a whole nother machine. So obviously there's the cost factor. Now you have to purchase 2 machines, but there's a huge space factor. Now you have to have enough bench space for 2 machines. We have kind of destroyed that narrative with the print pods, because the print pod system is compatible. It's essentially an addition to the Max series machines. So now you have one machine that can do it all, and it does it all very well. And I think there's a huge advantage to that. So I suppose you could see the print pods maybe as a response to the Midas, in the sense that it's kind of addressing a similar market need. But it is far from a Me Too product. It is contrasted in many ways that I think really sets it apart as an effective clinical solution.
Yeah, I remember I talked to you guys at IDS, and I have to be honest, I really like the idea that it can reuse the pods. I think that's genius. And it definitely, you guys beat around the bush a little bit, because I know it's awkward talking about other companies, especially when you guys are going to go public, but I can say it. I think that's like a direct, we do it better in a way, because the pods, or whatever, the capsules on the Midas being used once is kind of crazy. I mean, you see some people now, after they print the capsule, they drain out the resin to try one day use it in another printer. So I think you guys got something there on them, no doubt. It's interesting to me, though, because in some ways, I'll give you my 2 cents as someone who's been using Midas for a while. I'd love to use the pods once you release them, by the way. One thing about having a printer that only does one thing is it really helps simplify that one thing. And you guys could say, look, well, then just buy an Asiga Max and attach the pod attachment. But it's just the form factor. It's not a 3D printer. It doesn't even feel like a 3D printer. And I guess that's what kind of is quite edgy and cool about the Midas. But I totally agree. I think the fact that you can have a do-it-everything printer and then add this attachment and then have access to this thing that these guys are making so much noise about is a really fascinating move. I think it was a power play in ideas, to be honest, and I think it was one of the cooler releases. I want to stop talking about Midas and you guys, because I'm sure you're sick of it. Let's talk about the industry, though. Do you think this concept of these capsule printers, whatever you want to call them, pod printers, capsule printers, is this going to be a new kind of breed of 3D printer for chairside?
I think so. I mean, like cartridge 3D printing is not new. And so like 3D Systems, they released a cartridge printer called the Project 1200. They released that like 10 years ago, I think it was. And it just never really took off. It had some issues and some flaws, but also I think a lot of people that were using it in dental didn't know really understand 3D printing. And the market just wasn't mature enough to be able to take on that technology. And then like DFAB, which is DWS, they've had a cartridge printer for quite some time.
That didn't take off, by the way. Sadly. I love the DFAB guys, but that really didn't take off.
It really didn't take off, and it's actually quite innovative. Like they have
multi-layers.
Like that's So they have some really cool technology, and so but I think the main issue that we encounter with these with the cartridge-based technology systems is that they're all closed on the material science side, and so with the DFAB, you have to use their material. With the 3D Systems, you have to use their material. With the Midas, you have to use their material. And what happens? Like, there's the companies that have these locked systems. They're not like, yes, they have some resources to be able to play with some of these new generation materials, or maybe they can partner with some companies that maybe has access to it. But there's so many more companies out there in the dental world that are strictly a chemicals company, and that's what they specialize in. Like, think of the companies that make these true amazing composites that you're using chairside. Being able to convert those into 3D printed resins that's being done, and that you're going to see these materials in the Asiga PrintPod system, and you'll actually have like true permanent crown materials that clinicians have been trusting for the longest time, and now they'll be able to 3D print it. And with the closed system machines, you just won't have access to it. And I think that's been the Achilles heel for a lot of these systems. And then you get locked out of the natural competitive forces that drive prices down. And so being able to purchase a material at a lower cost, you'll be able to get that with the Asiga system, just through natural competitive forces. But I think that the cartridge technology, it solves quite a few problems, and it's here to stay. And it's not just a fad. I think we'll see that there'll be quite a few individuals that will trust in the cleanliness, and they'll really enjoy the ease of access and the ease of use. Like, I was tickled pink when I was playing with the PrintPod system when I was in Australia. It was the first time that Bryce and I had the ability to print with it. And literally you unbox your machine and you perform the initial calibration with the standard build platform. And then you'll simply place in the adapter kit, and you can start printing with the PrintPod systems right away. In fact, like, I would literally scrape off a build and then start the next build immediately. No worries about like leveling the product, no worries about any of like the potential headaches that you can run into with general 3D printing, and it just was repeatable print after print. And so it was pretty amazing. Like, we did a 3-unit bridge in, I think it was like 25 minutes or 20 minutes. And so being able to even tap into maybe some larger span applications, you have that accessibility with the PrintPods. And so it's amazing. I think it's really going to unlock the next generation 3D printing for chairside, but also I think it will also open up an opportunity for laboratories to get into fabricating restorations at a lower cost. And so you always have certain situations where maybe you need to produce a restoration right away, or you want to try a new material, but you're not really sure you want to get into 3D printing it, and maybe you want to still mill it. There's by utilizing the PrintPod system, it introduces a very low entry cost point for fabricating crowns. And so, and let's say if you end up not liking it and you want to move to a different style of manufacturing, which I highly doubt it. I mean, everybody that has been exposed to the PrintPod system absolutely loves it. But if you, for whatever reason, migrate away from utilizing the PrintPods, well, you can still use your machine for any dental application. And it really saves you the potential risk of buying a piece of equipment and then having it turn into a paperweight. And so the most expensive piece of equipment you own, doctor, is the one that you're not using. And I'm sure you have pieces of equipment that you thought was going to be revolutionary and thought was going to be game changing. Use it a couple times and now it's sitting in a back room. And with the PrintPod system being that it's convertible to be able to use the PrintPods and then switch back to a standard Asiga Max, you'll always find use for it and always find ways to generate revenue.
I'm curious. So with the PrintPods, is it only for the Max 2 at the moment, or which
It can
which
be.
printer can use
So
it?
it's for all Max series printers. Now, if you have an original Max, or if you have a Max 2 that has the clamping system like the original Max, you can use the PrintPod system. There is a little bit of a conversion process. Essentially, we have to replace that top piece, but that's very inexpensive and it takes about 5 minutes to do. Really, at the end of the day, the PrintPods are going to be compatible with all Max series printers. We will also eventually be making these available for the Ultra series machines as well. But we wanted to start with the Max because we have the largest install base. You know, the Ultra is a much newer machine. We wanted to go with the Max because we wanted to make sure that the most number of people had access to this right out of the gate without having to buy a new machine.
Interesting. And the other thing I have a question about is, I love the fact that you guys with the pods are still totally open. That's amazing and totally on brand for Asiga. That was the reason why I bought an Asiga originally. It was just I needed access to materials where I had a whole bunch of closed printers. How does it work? So these are, because some people may be imagining a pod that you pour resin into. That's not how it's going to work, right? These are manufactured with resin manufacturers, specific ones, and you guys are going to release them. There's no pouring into the pod or anything like that. Is that correct?
That is correct. So these are pre-filled materials from the material manufacturers and suppliers. Yeah.
And who are you guys starting with?
So we have relationships with companies like with Keystone, with Vita, with Voco, PacDent, with Dentsupply, with Prothesia, with Dentona. Like every company that makes a permanent crown material for 3D printing today is on board for the PrintPod system. And then we have revolutionary like resin manufacturers, which really may not have really dipped into 3D printing that heavily, but they make amazing restorative materials that are composites. Those companies are also working on their own formulation for the PrintPod system as well.
That's interesting. One other thing about the pod that I have to ask, because you said you're printing up to 80%. What's so special about the pod that's allowing you to do this compared to just a crown kit? I mean, Midas will say they have the press technology and it's a press printing and that's how they get to do that. What's so special about a pod and a build platform that's allowing you to unlock these materials?
Yeah, I think the biggest thing is that the surface area is much smaller, so the approach and separation forces are reduced significantly because it's a smaller build envelope. The other thing is that it's a combination of like you couldn't just take our print pod and put it in any printer and then have it work. And so you may be able to work with some materials, but the viscosity may overwhelm some other printing technologies. Because we utilize, we have like one of the strongest vertical stages. So the Z-axis rail that the build platform moves up and down on, it's one of the most robust rails that you can fit inside of a 3D printer of this size. And then combined with our SPS technology, so our smart positioning system, we're able to analyze those layers and make sure that they're formed equally and properly. And so it's a combination of both having an extremely well-engineered machine that's strong and robust, and then combining it with a smaller resin build platform, which alters the approach and separation forces.
Interesting. And I guess the other thing that's coming to mind, so people that may be listening are thinking about the crown kit that you just released and now the pods, and they're trying to figure out which one do I choose? What I'm hearing is that the pods really are made with chairside dentistry in mind. It's a lot cleaner than having to pour out anything. There's no build platform. There's none of that. But more importantly, it's inventory. It's that you can stock a whole bunch of different resins and not be worried about, like having this bottle of resin expire, etc. Is there any other main benefits between one or the other? I mean, how are you guiding your customers whether they go for a crown kit or a pod?
Yes.
Bryce, you want
Yeah. Sure.
I talk a lot, so I don't want to. I want to make sure it's shared.
The end result obviously is a restoration with both of these. I think it really comes down to, I think the pods are an even more cost-effective solution, and I think they're more conducive to trying new materials, first of all, and stocking materials. So when we look at trying new materials, right? The pods are about this big. They look like about that big around, about that tall. They look like a little pill bottle, basically. I can't tell you exactly what the price is per pod because it will depend on the material. So we aren't dictating to our material partners how much they sell their product for. So you're going to see a variation in pricing. So some materials may be $20 per pod. Some of the more unique and innovative materials may be a little bit more. They could be $30 or $35 per pod. But even still, even on the high end of that, $35 to try a new material, maybe you're one of your buddies says, "Hey, I just tried this new XYZ material in the pod system. It was great. You should try it out." $35 to try out a pod is a pretty easy sell compared to a $600 bottle of material that you may or may not even like. Right. So that's a huge advantage of the pod system. And then just overall cleanliness in stocking, it's pretty easy to stock little pods. You don't have to have a ton of space for big bulky bottles. It's just an overall cleaner and more aesthetic solution for the clinician than the crown kit. I love the crown kits. They're great. They're fantastic. The print pods just kind of take it to the next level.
And I guess it's amazing, and it all sounds really fascinating. Can't wait to try it, to be honest. When do these actually come out?
Yeah, so the print pods themselves, so when we announced them, I should say, announced versus release. So when we announced them at IDS, the print pods that we had at IDS, they were all prototypes. And so they were actually 3D printed prototypes, but because they're 3D printed on an Asiga system, you couldn't actually tell. And so they literally looked like they were injection molded. And so they looked fantastic. So after IDS, the team went straight to work and they had to redesign the print pods for injection molding. And so that took a little bit of time. And then after you have something developed for injection molding, you have to go through a tooling process. So that's where we're at today. And so we're going through this tooling stage. That does take a bit of time. And then once that's completed, we'll do our first round of shots for injection molding. And then all of our empties, the print pod empties, will be supplied to our material partners. And so then they can start doing their validation. So I think in the very beginning, we'll see some materials closest to the end of the year, end of this year for availability for the print pod system. For some of the more exciting and more innovative materials, we'll see it at the beginning of next year, realistically, because there is a regulatory process, and depending on the region that we're submitting for the regulatory process, it may take a little bit longer. For example, like MDR in Europe, they have a few more hurdles that they have to go through versus like the FDA or TGA, for example, or Health Canada. And so, so realistically, we'll see print pods most likely the earliest at the end of this year, and some more innovative materials next year.
Exciting times, man. Exciting times ahead. I can't wait to see it and hopefully get my hands on it. The other last thing, I need to wrap up. Guys, we could talk for another 45 minutes easily. I mean, I'm loving every minute of this. But you guys also had a shaker at the IDS booth. Is that happening? Or that was also just one of those...
Well, it's still on the books for happening. And so they, with the print pod system, we're looking at so with 3D printing, you have to print wash cure. Everybody knows it's a process, print wash cure. For washing parts, there's so many times that washing gets, for like a simple application like a crown, it can sometimes be overcomplicated. And so instead of having this elaborate washing system that's just for a singular small crown, our engineers came up with an idea of, hey, why don't we just have a shaker? And so it's literally just it's called a pod wash, and And so you'll, after you finish with your print pod, you'll take the magnetic stem off the build platform adapter. You'll put it in this tube. It looks almost like a test tube. You'll put your IPA or alternative cleaning solution, depending on what's needed for that material. You'll tighten the lid, and then you'll just shake it for maybe like 10 seconds, and then your part is clean. And what that helps eliminate, it eliminates the extended exposure for the glass-filled ceramics to alcohol, which can cause that like white powdery defect that we'll see on parts if you let ceramic resins soak in alcohol for too long. And it's super quick and super efficient. And so it was one of those things that it's like, it doesn't feel right how simple it was, but it was quite simple and actually quite elegant for what we need to achieve.
And so that's coming out with the pods.
Yeah. So that'll be released with the pods.
Oh, that's awesome, man. Look, guys, I guess to wrap up this episode, which was jam-packed with information, any last words, any exciting things you guys are seeing in the industry? I mean, I would have loved to have more time to talk about the industry and what's happening, but I think every episode it's almost the same message. But, you know, for the last 5 minutes, I guess, what have you guys seen? What are you guys advising clinicians and labs to keep an eye out for?
Yeah, you know, I think for me, the last few trade shows I've been to, including IDS, I'm excited about AI advancements. I know a lot. This can be a bit of a controversial topic, you know, with AI, but I think it's going to be a net good. I'm excited to see where it goes. You know, obviously, as we discussed here today, we have our own irons in the AI fire, so to speak. You know, working working in Funnel and working in Genira. But if you walk around really any trade show, it's like nowadays every other booth seems like it's got some kind of AI, you know, AI something or other in it, and I think that's exciting. I think we're going to see the winners rise to the top, and the those that maybe don't have as good of a product, they won't make it. But we see this with all products. And I'm excited to see where AI takes us in the next, 3-5 years.
I mean, I think for the market itself, it's just continuously evolving and everything is getting better. Everything is getting smarter. Everything is getting stronger. And so I think the area that I'm just the most excited about in digital dentistry is just the continued openness that we continue to see. And so that's something that we're actually proud of here at Asiga. And I think for those that are wanting to invest in technology, always invest in open, whether it's your 3D printer or it's your intraoral scanner or it's your mill or whatever it is that you're investing in for digital dentistry. Make sure it's open so you're not locked in with anything, and you'll ultimately be happier in the long run with what you invested in.
All right, guys, that's a wrap for today's episode. Massive thanks to Cory and Bryce from Asiga for waking up at 5 a.m. to chat with us. That's dedication right there. If you want to dive deeper into any of the products that we discussed today, we'll have links in the show notes plus a full write-up on the blog at instituteofdigitaldentistry.com. And look, if you found this episode helpful, do us a favor. Share it with your colleague who's been thinking about getting into digital dentistry or 3D printing. These conversations are how we all level up together. We drop new episodes every 2 weeks, so make sure you're subscribed wherever you get your podcasts. And if you've got any questions about anything that we have covered today, or if you want to suggest any future topics that we should cover on the podcast, hit me up on Instagram at idigitaldentistry or send us an email. Until next time, keep pushing the boundaries of what's possible in your practice. This has been Dr. Ahmad Al-Hassiny with the Digital Dentistry Decoded podcast. Thanks for listening.